Hi viewers, I am creating these videos to help teachers of maths support their learners in making sense of mathematical concepts and their associated processes and procedures. And what I thought I'd look at today is introducing fractions, because I think that in introducing fractions in the way we often do in this country, we cause ourselves problems. And we cause ourselves problems, particularly in them moving on to pupils calculating with fractions. And I think there's better ways of introducing fractions using the physical manipulative that will help us much later on when we come to calculating with fractions. So if you think about, a typical introduction to the idea of a fraction might be with a shape, something like this. Ideally, that would be a proper rectangle, of course, broken down into an equal number of pieces, and we're going to pretend that these numbers of pieces are equal. So there I've got 6 equal, in inverted commas, pieces, and maybe I shade 5 of these or something like that. And people don't often start with 6 and 5 of them, but there we are. And so, what we teach students is that this is 5/6 because it's broken into 6 equal pieces and 5 of them are shaded. And so this becomes 5/6, and this is how we write it, because there are 6 equal pieces and 5 of them are shaded. Now, the problem with that is that what we are seeing here is we are seeing a fraction doing the job of relating two integers. 5 and 6 are being related in this way. And although that's a perfectly valid view of fractions, it's not a particularly good view of fractions for calculation purposes. Because if I then say, right, well, now let's take this and then say break it down into this time 4 equal pieces, and again we'll pretend that's a proper rectangle with 4 equal pieces and shade 3 of them. I think it's easy to see where the misconception that if I add this to that, I will get 8/10. Yeah, because I have 5 shaded pieces here and 3 shaded pieces here, so that's 8 shaded pieces altogether, and I have 6 pieces altogether here, and I have 4 pieces altogether here, so that's 10 pieces altogether. And I think you can have quite a lot of sympathy with pupils that make that mistake, because this is their sort of concept of addition and how addition works, and this is their concept of fraction. It's just about the number of pieces, and what we lose when we do this is we lose the relationship to the value of 1. And of course, it is right here that 5 out of 6 and 3 out of 4 in that way would give us 8 out of 10. There's no denying there are 8 shaded pieces on that screen and there are 10 pieces altogether. But what we're losing there is the fact that this and this are supposed to be representative of one whole, of the value of 1. Yeah, this rectangle is supposed to have a value of 1. And this rectangle is supposed to have a value of 1. So if I add these together, what I am actually saying is, well, what I've got is sort of something out of 2, because these are 2 one wholes, not something out of 1. And it is possible to actually do fraction addition like that, but it's not particularly intuitive and not particularly nice. So rather than something like that, what I'm going to suggest is that there's an alternative way of introducing fractions that focuses much more on them as single values, which is what we want if we're going to operate with them. We want fractions to be seen as single values. When you add things, you add 2 single values, or you multiply 2 values, or you subtract or you divide 2 values. We need to be seeing those things as single values, not as the ratio of 2 values. Then I would be bringing in my Cuisenaire for this, and I would be hopefully already having pupils familiar with the idea that if the white rod is 1, and I'm going to show the values here, that if the white rod is 1, then all of these values are taken by the other rods. But then what I'm going to do, and I'm going to turn the values off now, is to say, right, well, we're used to what these are if the white rod is 1. but what if the red rod is 1? What values do the other rods have? And so we would look at that and go, well, okay, so this, children, and kids sort of will have to be told this, that this is half. This is 1/2, because it is half the value of 1 whole. It's half the length of a whole, or because it takes 2 of them to make the value of 1. Similarly, of course, this is 1, and then this I would introduce as 3/2 at this point, because it is 3 times longer than 1/2. And then, of course, we can turn around and look at it and go, well, this is the same length as this and that together, so it's also 1.5, and we can get to the sort of mixed numbers idea here. And then this is 4/2, but that's the same as 2 wholes, because it's twice as long as the value of 1, so it's 2. Yeah, 4/2 is 2, and then this is 5/2, and so on. And what I'm trying to motivate here, and I'll talk about explicitly, is the idea of the fraction family. All of these are now in the fraction family half. Yeah, they are halves. And when you do that, what you do is you're sort of giving the numerator and the denominator their sort of, in terms of fractions as values anyway, their proper role. Yeah, because if we look at something like the fraction 1/2, then we can see that what we actually have here is one of these things. What a length of 1 in the fraction family halves. So this is the numerator. It enumerates how many I have, or what length I have, what value I have. And this is the denominator, literally the name of the fraction, the name of the family. So this is, I have 1 of these things called halves. And of course, you can move on from there and say, right, well, what if, you might go through these. What if the green is 1? What if the purple is 1? What if the yellow is 1? Well, if the yellow is 1, then of course, this is 1/5, because it takes 5 of them to make the same length as 1. And this is 2/5. The red rod is 2/5, because it is twice the size of 1/5. It is equivalent to something 2 times longer than this. So it is enumerating. It is telling you how many times, or what value it has in comparison to the unit for this, if you like, which is 1/5. And then we have 3/5 and 4/5 and so on. And then obviously 5/5 is the same as 1. And we can carry on 6/5, which is equivalent in length to 1 whole and 1/5, and so on and so on and so on. Now, when you sort of introduce fractions like this, you get a lot of those sort of fraction properties that kids get confused with, almost taken for granted, because you get something like, 3 times a fifth is 3/5 rather than 3/15, which would be a typical incorrect response from pupils because they can see this. But what you also get is sort of these, because you're seeing these fractions as values, you don't get these sorts of mistakes that are highlighted with addition. And I do have a whole other video on addition of fractions, which I would suggest you go and watch at some point. But now, for example, let's say I want to represent 5/6. Representing 5/6 becomes, right, well, first of all, I have to choose my value of 1. And we keep that relation to the value of 1, which is so important when we're thinking about fractions as values. So I'm going to choose my value of 1 to be, say, this. And then that would therefore be 1/6. So 5/6 is 5 times longer than that. So this would be 5/6. So here we're seeing 5/6. This is 5/6 of my length of 1. But of course, what I can't do on that same whole is represent 3/4, because I've got no rod that is a quarter of this. I've got none of these rods, which is a quarter, because I'm dealing in the fraction family 6. And of course, and I will do a video on equivalent fractions as well, and simplifying fractions, where we get into choosing a whole so that we can represent more than one fraction simultaneously, or more than one family simultaneously. and stuff like that. But we can probably potentially see where that is going. So the advantage that this has, like I say, is that now this is a single value. This is the fraction. This here, this yellow rod, this is just defining my length of 1. It's defining the family of fractions in which I'm going to work. But this is the single value of the fraction. And long term, that makes it much easier to add with, to multiply with, to subtract with, to divide with. So that is my short video on introducing fractions. As always, I'd like to say a big thank you to MathSpot and its creator, Jonathan Hall, for creating this fabulous website, which I am using to sort of help create all of these videos. But it's not only got the sort of virtual manipulatives that are proved so useful in this, it's got a wealth of other material on there that will make your life as a teacher of maths easier. So I know I say it every time, but if you have not been through that website and had a good look at all of its toys and what you can do with it, then please do take the time to do so. You will not be disappointed. And again, as always, if you are sort of interested in using visuals and manipulatives to support your pupils in making sense of mathematical concepts, then please do check out my website. My website is visiblemaths.co.uk. And among the many things you will see on there is you will see a link to my book, which is also called Visible Maths. That's why the website is called visiblemaths.co.uk. And on my website, you will find a link to my book on the publisher's website. The publisher is Crown House Publishing, and there you can see some sample pages. And if you feel like it will be useful for you to sort of make that step in your practice to using more manipulatives, more visuals, then of course you can place an order. I will be creating these videos throughout lockdown and potentially beyond as well. So if there is a particular concept or process or procedure that you think I'd like to see that modeled with manipulatives and or visuals, and you know how I might help my learners make sense of that concept, process, procedure, then please do get in touch and I will hopefully get around to making it for you. Thank you very much for your kind attention.